Math 1960 Calculus 2 UNO Summer Session number 3. So here we're going to discuss integration by parts. Integration by parts is a technique that is very important in mathematics, especially when you have two functions that are multiplied together and you want to integrate them. Sometimes it's hard to integrate them using techniques that you know. So that's why it's important to use this technique called integration by parts. So here we're going to do integration by parts for indefinite integrals, and then we apply it to definite integral. So first we will derive a formula for integration by parts. So in this, let's say u is equal to f of x. That means du would be equals to f prime of x dx. Let's say we have v equals to g of x. That means dv would be equals to g prime of x dx. So we know about the product rule, that if you have product of two or more functions multiplied together, and you take the derivative of this function, for instance f of x times g of x, if we take the derivative of these two functions, we're going to get f of x times g prime of x plus f prime of x times g of x. So if we take the antiderivative of both parts of this equation, so we're going to get f of x times g of x equals to integral of f of x times g prime of x dx plus integral of f prime of x g of x dx. So now let's solve the equation for this. So then we're going to get f of x g prime of x dx equals to f of x g of x minus integral of f prime of x g of x dx. So now we substitute. So here we're going to have integral of u times du equals to v times u minus integral of du times v, and that would be the formula we will use to find the integration by parts. So our first problem, we want to apply the formula of integration by parts of integral of u dv equals to u v minus integral of v du. So first let's choose u to be x, and then du would be equals to dx. So let's choose v or dv to be equals to e to the x dx, then v be equals to e to the x. So that means our integral of x e to the x dx, it's equals to x e to the x minus integral of v, which is e to the x dx. So that would be equals to x e to the x minus e to the x plus c. So same here, we want to choose u to be equals to x. That means du is going to be equals to dx. V is going to, dv is going to be equals to sine of x dx. So v would be equals to negative cosine of x. So applying the rule x sine of x dx, so I have u times v going to be negative x cosine of x minus integral of cosine of x. So negative and negative become positive dx. So then I have negative cosine, negative x cosine of x plus sine of x plus c. So that should be our final answer for problem number 2. So tips in choosing then dx. Dx is always part of dv. We saw that, right? And dv should be easier to integrate. Like every time we are choosing functions, we need to know, like, you know what, if we want to choose u, this u is going to make my life easier, and this dv is going to make my life easier. So the integral, the final integral, which is integral of v dv, should not be harder than the first integral, which is u dv. Should not. So every time you choose the wrong u and the wrong dv, the problem gets complicated, and you can redo the problem to make it easier. So if we have e multiply with a with a polynomial like this, usually our choice of u would be that polynomial. And if we have a trig function multiply with polynomial, our choice of u would be that polynomial, and the remainder would be dv. Okay, but if we have polynomial multiply with sine inverse of x or cos inverse of x, our u usually would be equals to the sine inverse or the cos inverse, and what remains would be dv. So problem number 3. So first we're going to choose u to be equal to ln of x. Then that mean du would be equals to 1 over x dx, and then dv is going to be equals to dx. That means v is going to be equals to x. So integral of ln of x dx going to have x ln of x minus integral of Okay, 1 over x, so x times 1 over x dx, x ln of x minus integral of dx. That should be equal to x ln of x minus x plus c. So that should be the final answer for problem number 3. In problem number 2, probably need to uh, do the problem twice, or we do the integration twice. So here, if we choose u to be equals to x squared, that means du is going to be equals to 2x dx. And then if we choose dv to be equals to e to the x dx, that means v is going to be equals to e to x. And then now we do the integral x squared e to the x dx is equals to x squared e to the x minus integral of so here I'm going to have 2x e to the x dx. So this is another integral again, okay? So that would give me some sort of x squared e to the x minus 2 integral of x e to the x dx. And that we find this integral earlier, and so if we insert that integral, then we get x squared e to the x minus 2. So the integral we found earlier was equals to x e to the x minus e to the x plus c. X squared e to the x minus 2x e to the x plus 2 e to the x plus 2 times 2c. So then that would be equals to x squared e to the x minus 2x e to the x plus 2 e to the x plus capital C. So 2c, we may call that capital C. So a constant times something is going to be another constant. Okay, so in this problem, this would be a lengthy problem. So we want to find the integral of this. So our choice of u, we're going to choose u to be, so let's say u is equals to e to the 2x. That means du be equals to 2 e to the 2x dx. And then let's choose dv to be equals to cosine of 3x dx. So now when we integrate this, we're going to get v equals to, so integration of cosine of 3x, it's going to be equals to sine of 3x divided by 3. So then when we apply our, we're going to get, so u times v equals to e over 2x times sine 3x over 3 minus integral of u times v, integral of v times du, and that should be equals to, so du here is 2 over 3 integral of e 2x sine x dx. So now, so we are going to do the integration of this part alone. Let's do the integration of this part, and then we insert it in. So for the integration of this, so u is going to be the same, but dv would be equals to sine of 3x dx. That means v equals to negative cosine x over 3. So then when we apply that that integral, we take it up by itself apart, we're going to get so v times u, it's going to be equals to negative e 2x times cosine 3x over 3, and then so we have a minus here, right? Minus from that cosine times the minus that comes there, that would be a positive integral from integral of cosine 3x over 3 times here I have another, here I have 2. Okay, so of what? Of e of 2x dx. And then if you look at this one here and the problem we started with from the beginning is the same, right? So that means we're going to say, okay, going to say our integration really of this function e of 2x cosine of 3x dx, it's equals to e of 2x sine of 3x over 2 minus, so here I have, so here 2 times 3, so when we times that, I'm going to have a plus. It's going to be plus here, so we're going to times this, it will be plus 2 over 9 e into x cosine of 3x plus, so 9 4 9 integral. So it's going to be integral of cosine. I don't have space here, so I'm going to put it right there. Integral of, so because, oh sorry, because here I have so it's going to be integral of, okay, here I have a negative here, then here I have a positive, so then I'm going to have a negative. So just 1 minute, wait for me. We're going to have negative. So here I'm going to have a negative of 4/9 of the integral of e to the 2x cosine of 3x dx. So this is similar to the problem we started with. So that means at the end, summing up these, I'm going to have the following. I'm going to have 9 over so here I'm going to have 9. Sorry, what did I just say? So here, let's erase this. So we're gonna erase this one. So the final answer should be for the following. We should be having, this is our function that we started with, e into the 2x cosine of 3x dx. That should give you e of 2x sine 3x 3 plus 2/9 e into 2x cosine 3x minus 4/9 e into 2x cosine 3x dx. And then if we take this to this side, we're going to have 13/9 of e of 2x cosine 3x dx equals to e of 2x sine of 3x over 3 plus 2/9 e of 2x cosine of 3x. So now we're going to say that e of 2x cosine of 3x that we started with, it's equals to 9/13 of e of 2x sine 3x over 3 plus 2/9 e into 2x cosine of 3x. So that should be the final answer. So at this point, we're going to use a definite integral to evaluate this. So we say our u is going to be equals to x, du going to be equals to dx, v or dv be equals to secant square of x dx, and then v at this time would be equals to tangent of x. So our integration from 0 to pi over 4 of x secant square of x dx, that should be equals to x tangent of x. So this we evaluate that at 0 and pi over 4 minus integral from 0 to pi over 4 of tangent x dx, and we should get pi over 4 minus ln of secant of x, evaluated from 0 to pi. That should be equals to pi over 4 minus ln of square root of 2. That should be the final answer.